In this video, we are going to find integers x and y such that the difference of their cubes is equal to their product plus 61. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step will be to factorize the left side, which gives x minus y multiplied by x squared plus xy plus y squared equals xy plus 61. Furthermore, I'm going to write this expression x squared plus xy plus y squared in terms of the other two, x minus y and xy, which is x minus y all squared plus 3xy. So this part multiplied by x minus y would equal xy plus 61. Then we can let x minus y equals a and xy equals b. From the original equation, since we need x and y to be both natural numbers or positive integers, that means the right side is positive. So that means x cubed has to be larger than y cubed. That means x must be larger than y. So since x is larger than y, we have a and b to be both positive. Now the equation becomes a times a squared plus 3b equals b plus 61. Then we can expand the left side, a cubed plus 3ab equals b plus 61. So 3a minus 1 all multiplied by b equals 61 minus a cubed. Now, if I make b the subject of this equation, it will be equal to 61 minus a cubed over 3a minus 1. And by definition, this has to be larger than 0. Since we know that 3a minus 1 is always positive because as a positive integer, a is at least 1, so 3a minus 1 will be at least 2. So therefore, the numerator of this fraction is also positive. But this gives an upper bound on a cubed, and hence on a. Since a is a positive integer, a can only be equal to 1, 2, or 3. Then we can test each case one by one. So when a equals 1, b equals 61 minus 1 over 3 minus 1, and that's 30. When a equals 2, b is 61 minus 8 over 6 minus 1, and that's 53 over 5, so we can reject it because b is then not a positive integer. Finally, when a equals 3, b equals 61 minus 27 over 9 minus 1, and that's 17 over 4. Again, not a positive integer. So the only solution comes from the system x minus y equals 1 and xy equals 30. But this is easy to solve because we know that x equals y plus 1. So we can put this into the second equation on the product. Then we have a quadratic on y. So y is 5 or minus 6, which we can reject the negative case, and so therefore x is 6, and so this pair is the only solution to the equation. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.